Lesson 2.1. Use inductive reasoning. By the end of today's lesson, we will be able to successfully use inductive reasoning in mathematics. Let me show you two examples that require the use of inductive reasoning. Example 1. Describe how to sketch the fourth figure in the pattern and then sketch the fourth figure. So there's three figures here right now, and we need to find a pattern, and that is using inductive reasoning. So I see that in figure 1, the rectangle is divided into two parts, one shaded and one non-shaded. And then figure 2, 3 non-shaded to 1 shaded, and figure 3, 5 non-shaded to 1 shaded. So I'm seeing that for every figure, you have to add 2 more non-shaded regions. So I would describe this as the rectangle is divided into 2 more regions. As its previous figure. So when I draw the fourth figure, first I draw the rectangle. I'm going to divide this up so that I have 2 more regions. And I have to shade this bottom left-hand corner, and I'm going to call this figure 4. Example 2, part A. Describe the pattern in the numbers. -1, -4, -16, -64, etc. Write the next 3 numbers in the pattern. So to describe this, we can say that each number is 4 times the previous number. Times 4, times 4, times 4. So -64 times 4 is -256. And the next one, okay, part B, describe the pattern in the numbers. And then write the next 3 numbers. I see that the numbers are increasing by 1.5. So I can write the numbers are increasing by 1.5. So the next one will be 7, and then 8.5, and then 10. So in conclusion here, we want to say that there's no proof to these patterns. So we call this a conjecture. A conjecture is an unproven statement that is based on observations. And you use inductive reasoning when you find a pattern in specific cases and then write a conjecture for the general case. So this will be your conjecture, and then your conjecture. Example 3. Given 5 collinear points, make a conjecture about the number of ways to connect different pairs of points. So let me first finish drawing my pictures. And 3 points, 4 points, 5 points. So if I have 2 points, They connected two ways. If I have 3 points, 1, 2, 3. 4 points, I could do 1, 2, 3, 4, 5, 6. So let me write these numbers down. And the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So let's look for a pattern here. Plus 1, plus 2, plus 3, plus 4. So the conjecture here is that for every increase in the number of collinear points, the number of connections would increase in this pattern we have here. I would like you to pause the video and try example 4, and then continue to play the video to see how example 4 is solved. So here I made a few groups of small numbers and try to find a pattern, and I noticed that the sum of any 3 consecutive odd numbers is 3 times the second number. So here is the conjecture. Now pause the video again and try example 5 on your own, and then continue to play the video for the answers. So for example 5 part A, it's similar to example 4, where any 3 consecutive numbers, the sum of any 3 consecutive numbers is 3 times the second number. So 4 times 3 gives you 12. 5 times 3 gives you 15. 11 times 3, 33. 101 times 3, 303. And for part B, you want to test a conjecture about the sign of the product of any 4 negative numbers. So I just came up with a random example here, and my conjecture is that the product of any 4 negative numbers is a positive number. So, in conclusion, to show that a conjecture is true, you must show that it is true for all cases. And to show that a conjecture is false, you must find one counter example, meaning an example that will prove the conjecture wrong. So counter just means against. A counter example again is a specific case for which the conjecture is false. So let's look at example 6. A student makes the following conjecture about the difference of 2 numbers. Find a counter example to disprove the student's conjecture. The difference of any 2 numbers is always smaller than the larger number. So let's say I pick 1 and I want to subtract that from negative 2. Now the difference here will be 3. But 3, the difference is not smaller than 1. And 1 is actually the larger number of between 1 and negative 2. Now I would like you to pause the video and try example 7 on your own, and then continue to play the video for the answer. Now, the supplementary angles are always adjacent. A counterexample will be any 2 supplementary angles that don't share a common side. So here I have a picture. And now let's finish example 8 very quickly. The scatter plot shows the average salary of players in the NFL since 1999 and make a conjecture based on the graph. As you can see, ever since 1999, the average salary has been increasing. So we can say as the number of years since 1999 increase, so does the average salary. Of a NFL player. Okay, and then we're going to continue the lesson in class.